Very often in MATLAB, we're confronted with the situation where we want to multiply different vectors or arrays. This is a very common issue, and I see a lot of problems with it, and I see a lot of issues that students are having currently with it. So we need to try to understand exactly what's going on. So the situation I have like right here is where I'm trying to multiply, let's say some function e to the negative t over 4 times this cosine of 2t plus sine of 2t. Okay? Typical way that you would do this is you would define a t vector. Let's say I would do it from 0 in steps of delta t to some t stop, like that. Okay? And then what you would do is you would say, let's say y1 equals exp negative t over 4, and then I would say y2 equals cosine 2t, and then y3 equals sine 2t, and then basically try to create y by saying y equals y1 y2 plus y3. The question is this correct? Okay, it's not. Okay, and that's something we want to be careful about. When every time I'm doing these operations on these different vectors like this, I need to be very careful about their size. Okay, so there's two things to remember. One is to be careful about size, and then two is to actually have some idea what you want the answer to be. Throwing numbers into MATLAB is dangerous if I don't have an expectation as to what the answer should be. Okay? In other words, one of the things I know is that y here should be a single row or single column of numbers. It shouldn't be a matrix, but I could make it a matrix. Okay? So let's just say for sake of argument that this guy was a lot simpler, and let's say I had y1 equal to 1, 2, and y2 equal to 3, 4. Now, what you are expecting, if this was y1 and this was y2, you know that what you expect is that every entry in y1 is multiplied by every entry in y2. So the result that you would expect from doing y1 times y2 would be 1 times 3, so the first entry in y1 times the first entry in y3, and then another entry, which is the second entry in y1 times the second entry in y2. So I would expect something like that. All right? That's what you want to have happen. Okay, so this is my key second point here. I want to have an idea of what my answer should be. All right, now the problem I run into is if I actually go over to MATLAB and I type, let's say, so I've defined y1 here as 1, 2, and I've defined y2 as 3, 4. If I say y1 times y2, it says, hey, I can't do that. Incorrect dimensions for matrix multiplication. All right. So we need to better understand what's going on with MATLAB. So if I have this problem, if I say y1 times y2, and that is 1, 2, 3, 4, what's going to happen is MATLAB is going to try to approach this as a matrix operation. Its default value, or its default approach, is to approach everything from a matrix operation perspective. So it's going to try to say, let's multiply this row by this column. So it's going to try to calculate that and say, well, I've got 1 times 3 plus 2 times nothing. And so it says, boom, error, I can't do that, because that's an incompatible matrix operation. Okay? So that's not so bad. At that point, you see that error, and that's usually when people say, oh, well, that must mean that I need to do y dot star y2, and that'll give me the right answer. What you have to do is not goof around and just try out and see what works, because then you can really get yourself into a rabbit hole and end up hosing up your computer. And I've seen a number of people do that. All right, so you have to have some expectation of what you expect that result to look like so that you can know to do it properly. When I do y1 dot star y2, I'm going to get exactly what I wanted, 3, 8. Okay? All right, so here, let's try that. Y dot star, y1 dot star y2, I get 3, 8, exactly like I had expected. And that gets me to sort of my other point, which is to say that what I should really do before I do any kind of operation is I should always check the size of my vectors. All right? Size in this particular case doesn't mean how long they are, but it means both how long and in terms of how many columns and how many rows. Okay, so the size command, unlike length, if I do help size, okay, so D equals size X. For an M by N matrix X returns the 2-element row vector D equal MN. Okay, so if I look at size of Y1, all right, in this particular case, for this guy, I have M equals 1 row, N equal 2 columns. So this guy is 1 by 2. So when I run this size command, what I should get is, it says a row vector, so I'm going to get 2 numbers, 1, 2. All right, so if I type that, size of y1, I get 1, 2. And because y2 is the same way, if I type size y2, I get that. Same thing. All right, that tells me right off the bat that based on the way this guy is defined, that if I want to do an element-wise operation like I'm saying here, I'm going to have to do a dot multiply. All right, now this seems kind of trivial when I have only vectors with 2 entries, but you guys in your homework, you're going to have problems with thousands of entries. If you screw this up, sometimes you will get an answer. In other words, I may not always get an error. Sometimes I may get an answer, but that answer may be huge in terms of memory. All right, that's the thing I'm going to have to be careful about. All right, we'll look at an example of that before we're done here. All right, so let's say the real problem comes in where, let's say, again, I'm trying to do the same thing I'm doing here. I have a set of numbers here and a set of numbers here, and I want to multiply them by each other. Let's say, for sake of argument, that y1 was set up like this, 1, 2, and y2 was set up like this, 3, 4. Okay. Now I have a real issue on my hands. All right, because y1 times y2 will give me a completely different result from y2 times y1, and none of these will be equal to what I'll get with the dot multiply operation. Okay, so to understand this, I got to understand a little bit now about matrix operations. So let's do the first one here, y1 times y2. So I have 1, 2, and then y2 is 3, 4. If I do that operation, what happens is I take row times column. So that ends up giving me 1 times 3. So 1 times 3 plus 2 times 4, or 11. Okay? Now, over here, if I did, so in other words, when I did this operation, I got a single number. Okay? This is why I'm saying you got to think about what your result's going to be. All right? If you were expecting to get 2 numbers, if I did y1 times y2 in this case, well, I've got 2 numbers here, I've got 2 numbers here, but I get 1 number as the result. You want to check those intermediate steps to see if that's correct, right? And the way you would check that is using that size command, okay? That would give you some expectation as to what your result's going to be, all right? Now, in this case, let's say I tried y2 times y1, right? So if I had 3, 4 times 1, 2, this guy is where the real problem comes in, okay? Because what you're going to do is you're going to say multiply row and column. So I'm going to multiply the first row by the first column, okay? Multiplying 3 by 1 gives me 3. Then what I do is I multiply the first row by the second column. So 3 times 2 is 6. Now I do the second row times the first column, and I get that entry. Then I do the second row times the second column, and I get that. So in other words, I took a matrix with 2 entries and another one with 2 entries, and I got one with 4 entries. Okay, that becomes a real problem, and that's where I see most of the situations where people's computers get hosed, because they'll have a vector y1 that has 100,000 points and a vector y2 with 100,000 points, but their dimensions are different. And so then what they end up getting is something that is 100,000 rows by 100,000 columns, and it is huge in terms of the amount of memory that it's now occupying. All right? If you have 100,000 rows and 100,000 columns, you think about how many entries that is. That's a lot of entries that have now appeared. All right? What you wanted to have happen was y1 dot star y2, which is to say that you would get a result that would allow you to have 3 and 8 as 2 entries. Okay, so we got to be really careful about what we're doing in each of these cases. So let's say that I had that. Let's say my y2 was equal to 3, 4, like that, except that they were in a column. To make it in a column, right, I put that semicolon there. Now he's in a column. So if I do y1 times y2, I get the number 11, like I said I would. If I do y2 times y1, I get that matrix 3, 6, 4, 8. Okay? So I got to be really careful about the way that I try to make these things happen. If I do y1 dot star y2, all right, now that also becomes a goofy operation here because these guys are still not compatible, right? So all of these get different operations. What I tell you to do is to say, okay, well, look at the size of y1, look at the size of y2, and make them compatible. So here I see y2 has 2 rows, 1 column, whereas y1 has 1 row, 2 columns. So what I want to do is make these guys compatible. All right, so there's an operation that I can do, which is to say, I don't like this guy being vertical. So one thing you could do is say, well, no, hey, I should just redefine it so that it looks like this, all right? Then they're compatible. In other words, what I want to do, before you do operations, check that they're compatible by doing the size command. In other words, make sure that the things you're trying to multiply have the same number of rows and the same number of columns. If those are different, start over, all right, and redo it. One thing you can also do is you can do something called a transpose operation, which is something that exists in linear algebra, which is where you switch rows with columns. So one thing I could do here is I could switch rows with columns. So let's say I had y2 equal to 3, 4. So what I could do is I could say, you know what, I want to take every entry in this column and put it into a row. So the way you do that in MATLAB is you do a prime. All right, in matrix operations, linear algebra, you learn that as T for transpose. What that will do is turn this guy into a row vector. Okay, so what I do here, if I say I had y2 equal to 3, 4, like that, do y2 transpose with that prime, it becomes like that. So notice if I do size y2 prime, it's that. Size y2, it's that. If I transpose it, then I can do the operation. The critical thing for you, the critical takeaway for you is basically what I said here back at the beginning, right? I want to check the size, and I want to make sure that I have the same number of rows. So the two things I'm multiplying or dividing should have the same number of rows. So expand that. Same number of rows and columns. The number of rows in one should not equal the number of columns in the other, and vice versa, or else this becomes a real mess. All right, so let's go back to my original problem, which was this, okay? Which again, I would very often approach like this. All right, I'd create a t vector, which then makes y1 a vector, then makes y2 a vector, makes y3 a vector. If what I want to get, so if you think about this for a second, I define t. If t has 1,000 points, you would expect y1 to have 1,000 points, y2 to have 1,000 points, and y3 to have 1,000 points. So knowing that, you know that the solution, y equal to y1 times y2 plus y3, better have 1,000 points. All right? So you want to check the size of these guys before you do the operations. Okay? So let's look at an example of that. Okay? So here's a piece of code that I wrote that basically did the same thing. Okay? So in this case, I created a vector t1, okay, which goes from 0 in steps of delta t all the way up to 20 seconds. Okay? And then I create my y1 vector here, create my y2 vector here, and my y3 vector here. Okay? So let's take that all and evaluate that. And let's see what I get. Okay. So I do size y1. So y1 has 20,001 columns. y2 has 20,001 columns. y3 is the same. So to do the operations properly, I guess I'll call this guy y here. Okay. Y equals y1 dot star y2 plus y1 dot star y3. All right. That's the way that I do this operation here. Okay. I have to do that guy with the dot star. Okay. And that will work. I'll get the result that I sort of expected to have. Okay. All right. So let's run that whole thing. And there it is. I get something very, very much along the lines of what I would expect, which is a decaying sine wave. Now, let's say, for sake of argument, that those guys had been defined differently. All right, so here I create T2, which is T1 transpose, T1 prime. Okay, so since I already ran that code, let me type over here size T1. So T1 is one row, 20,001 columns. T2 is all the same numbers, but it has 20,001 rows and one column. Okay, so what I did here is I defined a y4, which is basically the same thing as y1, except I used the T2 vector. Okay, so let's take that guy, let's execute that. So now I take size y4. All right, so y4 is 20,001 entries. Because T2 had 20,001 rows, y4 has that result. Now, let's say I wanted to multiply that by y2. Okay, so y2 has 20,001 entries. y4 has 20,001 entries, but they're on different dimensions. Okay, so size of y4 is 20,001 rows. Size of y2, 20,001 columns. So let's say I did what I have right here, and I went through and I did y4 times y2. This is a really dangerous operation because I have something that has 20,001 rows multiplied by something with 20,001 columns. It becomes enormous when I do that. Okay, so if I run this guy here, evaluate selection, probably shouldn't type just X to see it, okay, because it would take it a long time to display it. Let me type size X. So 20,001 by 20,001. You know that is not what you wanted to have happen. Okay, so you got to check to make sure that these vectors are in the right the right order, the right sizing before you actually try to do any kind of operations. Okay, so the real problem is, let's say I tried to do this and I tried to make a plot of these guys. Okay, so this is really tricky. Okay, one thing about the plot command, all right, if I type help plot, okay, plots vector y versus vector x. If x or y is a matrix, then the vector is plotted versus the rows or columns of the matrix, whichever line up. All right, so what this means is it's going to try to plot basically every row or every column in this thing. So the plot command is basically going to try to make 20,000 different plots of 20,000 points. Okay, so think about that for a second. 20,000 different plots of 20,000 points each. So if I run this particular command, all right, I will regret it. All right, my computer's going to be busy for a while, and what I'm going to get is some crazy graph here, which is going to have all kinds of colors. All right, it's going to take it a while to do it. All right, and this is the type of thing that I see people run into all the time. Is okay, my computer's back to normal, but this guy is it's going to take up a lot of memory to do this, and my graph is going to be crazy looking. I'm going to try to let that complete. Give it a little bit of time. It's not done yet. You may think that it's done, all right, but it's not done, all right. So it's actually still plodding along. I'd have to wait a little while for it to actually come up with a result for me. All right, what it's showing me right now is my previous result. All right. So if you're looking at my clock, I've skipped ahead about 5 minutes or so down here. All right. So if you look at the clock, and I just skipped ahead. I edited the video out. There's the plot now. All right, so it's changed. Took it a while. All right, in reality, probably took about 3 minutes for that guy to graph. And you didn't necessarily know that it was happening, other than the fact that maybe the computer was a little bit slow to respond. You had a graph that you thought looked correct, but ultimately it was trying to plot this. What this did was it just plotted 20,001 points 20,001 times. All right, there's a lot of points on there, and that's why it took it so long to do that. There's 20,001 different graphs plotted on top of this thing. If I tried to zoom in, that's probably a bad idea for me to even try. So let me not do that. All right. And finally, my computer kind of slows back down. All right, so the really, really critical thing for you, the key takeaway of this, is to have some expectation. Go back to my two things here, right? My two things here have some expectation of what my answer should be. So if I'm multiplying a vector with 20,001 points by another vector with 20,001 points, and I expect to get a vector that's 20,001 points long, look at the size of those things that I'm multiplying and make sure that they have the same number of rows and the same number of columns, okay? And do the dot multiply to make sure that it works out properly, okay? This is the really key thing, because what I see people do is if you know that you're trying to multiply each element in one by each element in the other, and you do it wrong, like I just did right here, all right, you'll make a big mistake, all right, and then things like this plot will go crazy. So you really got to be careful about it. check your dimensions, and think about whether or not you need to do element-wise operations. If you're trying to multiply each element in a vector by each element in a vector, then you need to do the dot multiply. Okay? This element-wise idea means first entry times first entry is an entry in the answer. Second entry times second entry is the second entry in the answer. Okay? You have to think about what it is that you expect to see. If you don't think about that, and as I said here, think about what it should be. In other words, what size do I expect the result to be? And then check the size of the results, or the size of the inputs. So check the size of the inputs, have an idea what the size of the output should be, and go from there. All right?